Okay, I'll do that. 32. Let me see. Let me get it written down. Okay, so you're distributing. So basically, you're going to multiply these, but when you multiply power forms, you add the exponents. So here, h and 2h adds up to 3h. K negative k zeros out. Minus, now you multiply this times the next thing. Same thing. You add your exponents, so h plus h is 2h, and 1k minus 2k is minus k. And then the last one, you add exponents, you get h plus 2k. And there you go, done. All right, listen, we're just going to start. Get more questions. We can talk about it later. We're talking about exponential growth and decay problems now. And just so you understand, we're going to go over these now where we really just plug and chug. In other words, you begin the information for the formulas, you plug them in, it spits out an answer, and you're done, and it's nice. Later, after learning how to solve equations, exponential equations and log equations, we'll revisit these, and we'll do the problems where they give you the final answer, you have to solve for like the missing rate, the missing time. And then you have to solve either using like radicals or using log. And so I'm saying that we haven't covered that yet. So we're going to hit these formulas twice. Now you get familiarized with them, and then later we'll do them again. When we have the assessment over this, it'll be every kind of problem. The kind where you just plug them in, but mostly the kind we have to solve. Now, look, these formulas are worthless unless you know what everything means. And so most of it's pretty obvious. P is your principal amount or initial amount. A is the final amount after so many years. T is the time in years. And so if it's 18 months, that'd be 1.5 years that you'd use, right? And R is the rate, but as a decimal. So, 5% is not 5, it's not 0.5, it's 0.05, right? 1% is 0.01, because 0.1 is what as a percentage? 10%. So just don't make silly mistakes with the rate. The biggest thing people get confused about is n. And once again, when I say you're compounding, the idea is, that's when they recalculate your like they give you your interest, basically. They put the interest in the account, if you will. And so, and that's what compounding means. And so, n is the number of times per year that's done. So it's easy. If it's monthly, then n is 12. If it's quarterly, n is 4. Daily, n is 365, and so forth. Okay. All right. Now let's just start doing some of the formulas. So this one, initial amount of 2,000, then 1 plus the rate, 0.05. It's quarterly, so I would write this down. This is always the key word you need to look for. Quarterly means n is 4. And by the way, watch this. The other formula we use, which is also a compound interest formula, but this one is if you're compounding continuously. I told you, the more frequently they compound, the better, because you start earning interest sooner. And so daily was good, but if you do it every hour, that'd be better. Every minute, every second, every millisecond, every nanosecond would be better and better and better. You take it to extremes, and you get this, continuously. So I'm saying that's the word you're looking for. If the problem says it's compounded continuously, you use PERT. Whereas if it's compounding in time, a finite number of times per year, then you use the formula that has n in it. But like I said, you have to choose the right formula. Okay. N is 4. That's your denominator. And then 4 times t is your exponent. Something I want to mention is that people get n and t confused. And then also, they'll put t here when it's n that appears twice. All right, now let's just type the thing in. And just be careful. Frankly, with these newer calculators, it's harder to mess it up because you can type it in such a way that it looks like what's on your paper, much more so than you could in the past. And so $4,891 Any 4 cents? Yes? Next example, exactly the same, except for now n is 12. So all I want you to do is go in the calculator, do second enter. Or if you want, you can just retype the whole thing. But if you want to overwrite the 4s with 12s, I missed. You have to be careful. I guess. You can do insert if you want. I want to insert the 2. And you should get a. Okay, what did I do? Oh. Yeah, I don't have a closing census. That can be problematic. Okay, really? I give. I'm just going to type it in again. Divided by 12. Close to the power. 12 times 18. Is that what you got 2 minutes ago? And what, 2 cents? And we take it a step further. Do it daily. I'm going to make this work. Okay, and a slightly bigger answer. And once again, that's one thing you should appreciate is the more frequently you're compounding, the better. You try the next one. I assume you got what I got, 6,951 and 98 cents. Okay. All right. Now, once again, it's commented continuously. I would underline that word because that's your clue as to which formula you're using. And that's PERT, so the initial balance, times e to the power of 0.05 times 18. And you get e, like if you just want the number e, it's right below pi, but we don't want that. We want e to the power of. So do second natural log. So we're here, second ln. And I get 4,019. 21 cents. Yes. Yeah. Yeah, that's. I don't like this calculator screen as much. It's too small. try one more. Go ahead and do this one. Second. And then 0.04 times 8. Okay. Yeah, ideally, you made, when I say you're financially independent, basically you either have businesses or something that are making money for you, or you have so much money invested that it's making money for you. And the trick, of course, is being to be able to leave that money there and not have to use it. Not everyone has that luxury. But frankly, you could start now. So, after years and years and years, like 30 years from now, 50 years from now, it would grow quite a bit. If you can, start putting away some now. Okay, switching gears entirely. Now we're not talking about money. We're talking about like population growth or other things that grow. And look at this formula. What I want you to appreciate is really exponential growth is always like this, where, and by the way, R is either positive or negative, depending on whether it's growth or decay. And so think about this. If it was 2% growth, you'd have 1.02. That's 102%, right? Whereas if it's 2% decay, it's minus 0.2 gives you 0.98, which means 98%. Well, if you take 98% of something, you get less. And so your rate is being applied multiple times, and then this exponent is how many times you do that. And what I'm saying is, if I go back to these that we're just doing, it's the same idea. This is your initial amount. This is your growth factor, and it's growth in this case because it's exponential growth. I mean, it's compound interest. And what we did was we took the annual rate, 3%, split it up 12 ways, and so your rate is not 103% every month. It's smaller than that, but you apply it more often. So it's not just once per year, it's 12 times per year, so it's 132 times that you apply that rate. If I changed it to daily, you'd apply it a whole bunch more times, but it's a smaller rate then. But it's better. Applying that smaller rate more times gets you a better return if we switch to daily. So I'm saying it's all the same basic idea. Initial amount, growth factor, and number of times it's happening. And if you realize that, then if I throw something at you that kind of not matches any of these formulas exactly, you can still figure it out. All right, let's do this one. Is it growth or decay? Decay, because instead of declining, all you have to do is read. But that means you're doing 1 minus 0.026. I want to do this a little bit differently. Rather than just type in the formula, I want you on the calculator, type in just 11 million for now. And then press enter. And then type in times. Now, first of all, if you subtracted this, if you subtract 2.6%, you get 97.4%. So what I want you to do is do times 0.974. Press enter. And then do it 14 more times, so a total of 15 times. So that's 1, 2, 3. And don't lose track. And you should get that answer. And let me type in the formula this time. I'm going to type it in, 11 million. Obviously, we should get the same answer. Let's see, you can type in the 1 minus 0.26 or just type in the 0.974. Doesn't matter, same thing. The power of 15 And there you go. 7.4 million, roughly. So 7,409,297.6 what? What are the units? Huh? What are we talking about here? People, yes. I expect you to put units on your answers on every application problem all year long. Now, as to what we do with this. Listen, you can just leave it, frankly. If you talk about the national average of birth, number of births per family, it's like 2.1 something, or I don't know, I have to look it up. But they express it that way, and obviously no family has 2.1 children, and that's not the point. And so I'm just saying, this is the best answer, and what it actually means, you have to think about it. In this case, you're talking about population. I'm thinking the 0.6 person doesn't really count as a person. These maybe just automatically round down in this case. You can also just round the nearest person. That's not inappropriate. I'm not going to quibble over that, okay? We'll just leave it like this and move on, frankly. Next one. Oh, wait, I forgot. We're supposed to do 30 as well. So since you have the formula, just do second in there. And replace the 15 with a 30. And here, this definitely pays off to do it that way. So you can see after 30 years, it's lost more than half of its population. All right, you try the next one. This one, by the way, is growth. So you're basically multiplying by 102%. And then once again, change it for 20 years. Okay? Now, if you have something where it explicitly says it's continuous growth, then you have a formula that's like PERT. And so I would once again look for that word and underline it, because that determines which formula you're using. So now you put the initial amount, and then times e to the power of, and it's declining, so you use a negative rate, negative 0.026, times 15 years. And so let's type that in. E to the power of negative point. Right? And then once again, redo it for 30. Okay? Then we're going to skip that one. Changing gears entirely now. What I want you to do is type that data into the calculator, hit stat edit, and listen, first of all, what I'm always going to do in a problem like this is call the beginning time, beginning year 0, and just go from there. Your equation is going to look much nicer if you do that. Okay, so got 0 in there, 10 in there. If you already had data in there, watch. If you need to clear out previous data, highlight, you cursor up until you've highlighted the name of the column, and hit clear and enter, and then you can type in your data. Okay. Okay, now watch this. We want to calculate the regression equation. So do stat, calc, and which one do we want? And it's not one of these. Scroll down and tell me the number of the one we want to choose. Good. Yes. So 0. And you can just press 0, but I want you to see it first. And so, yeah, that's what we want for exponential regression. Okay, stop. And just press enter for everything. And when you calculate, press enter. And there you go, there's our equation. Come on. All right, so first of all, write that equation down. It's y equals 125 times 1.08 to the power of x. There's our exponential equation that matches this data. I want to get that into y equals. So here, watch. You can get the calculator to paste that in there for you. So on your calculator, hit bars, 5. Bars button right by the clear button. Choose statistics for 5. Right arrow to the EQ menu, and press enter, and it'll paste it in there for you. Do that one more time. So bars, 5. Now what? EQ menu, and just 1 or enter, yes. And it's pasted in there for you. Now, here's the thing though. I want to see not just that equation, I want to see the data. So if you have stuff typed in the stat edit, then when you're in the y equals, if you just get, here, look, up arrow till you hit the plot 1, press enter, and now plot 1 is on. So now those points will be plotted, okay? And then, watch this. To get the window setting set, you have a couple of options. You can do it manually, which may be even better, but if you hit zoom, zoom 9, if you have points, if you have it so it's plotting points, zoom 9 will fix it so you can see those points. Now, frankly, the window settings usually aren't ideal with this. What I mean is, like seed, by min, I would rather it be 0. Then I can see the origin that way. But it works. All right, now look at the next thing. We're supposed to predict 500. Now let me show you the mistake I made first period. I came in here, went in the table, and said, all right, I'm trying to do 500. So I typed in 500, went to the table, and saw that. Where did I mess up, first of all? Yeah, I put in the year 500, which is 500, the year 2500 then is what this represents. But it's good because it brought up a point. These models, I tell you, they don't last forever. So if it was true, then in the year 2500, that is 2.1 quintillion deer.
That's too many deer.
Yes. And just so you understand, if it'd be 6, 10 to the power 6 is a million, the power 9 is a billion, power 12 is a trillion, 15 is a quadrillion, 18 is quintillion. Yeah, that's not possible. That's not going to happen. So, yeah. So, I guess I could have left it, actually. Let me just put it back. So what did I just do? So what I should have done is, first of all, go back and not start there. And there's 2 ways to approach this. Just go to the table, make sure you have nice normal window settings, and just go down to your Y value of 500. Yes? Come on, this thing's, you wouldn't think. Because after 10 years, it's already at 260. Come on, it seems slow. We're getting there. Now, yeah, it's 18 point something. And it says basically when, okay, really? Please stop. Let me get back to 18. Yeah, it just wasn't keeping up, and I didn't realize how far ahead of it I was. All right, let's see. What is it going to do? Stop, 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 stop. Okay. Now, if you're using the window to do this, the table, it can be kind of clunky. We figure it as 18 point something. So what you could do to get a better answer is go to table set, type in 18, make you go by tenths, then go back to the table. Let me try that. So we want dependent to be asked. And then go to the table. And I don't know what it means by dependent ask because it won't let you type it in.
Yeah, you can hit enter the column and then put it in.
Oh, yeah, it'll calculate it only when you ask. So no, it doesn't do what we wanted. I didn't think so because it's been a long time since I tried that. So I couldn't remember what it did. So. All right. Like I said, we knew it was 18 point something. Go to the table now, go by tenths, and you say, oh, well, it's between 18.5 and 18.6. Okay? Now, I'll do it a different way. Go back here and go into Y2 and put 500 for Y2. And this would be a better way, frankly. Come on. And go to your window. And first of all, after 10 years, only is at 260. So, pretend we don't know the answer. I'm saying you figure, okay, it's going to have to be more than 10. We'll try 20, 25, something like that. Come down here, your Y max needs to be at least 500, right? And then hit graph, and you need to make sure you see the point where those cross. The horizontal line you typed in, and then our curve. And we wait. And once you get that, you just do second calc 5. Enter, enter, enter. And 18.54 apparently is the best answer. Goes around down, I think, 18.5 years. So really, the best way to do it then is to use the graph. We'll do it on the next one. All right, one more. Get into stat edit again. Type in your new data. Let's see, clear out the old, highlight the column heading, hit clear, enter. Highlight the next column heading, hit clear, enter. And I'm going to stick with the policy once again. The beginning year is year 0, and then so this year is 5 years after that. That's the data I'm entering. 0 and 5 from X values. And what were the Y values? 6.6. By the way, what does the 4.5 actually represent? 450. That's 450 and 660 because it's 4.5 hundreds and 6.6 hundreds. Now, we want to find the regression equation, so repeat that. Stat edit to get the data in. Stat calc 0 was for the regression, the exponential regression equation. Stat calc 0. So 4.5 times 1.08. The power of x, that's our. Once again, we want that in y equals now. Go to y equals, clear out what we had, and then tell me again how to get the equation pasted in there. Bars. 5, statistics, EQ menu, and 1, or enter. And then let's go and look at the next question. It says, when will it be 850? What y value are we looking for? 8.5. 850 is 8.5 hundreds, right? So I'm saying go in here, and we already have the equation in there. So put 8.5 in y2, and go to your window. And if I look at, this was after 5 years, so I think I'll keep the x values as I had them. They aren't horrible. And then y max of maybe 10, since I'm trying to go for 8.5. Once again, pig graph, and make sure you can see the intersection point on the screen. Maybe I should have chosen a smaller x value because it's trying to go all the way to 25, and it's just slow at calculating the exponential. But all right, we got it. And then second calc 5. What, 8.3 years? Except for one thing. The question was phrased differently this time. Because now it said, in which year will it surpass 850? And so just watch. What I want you to do is go back to the table. Now, I'm going to go and make this go by ones again. And here. You can see the y column hits 8.5, somewhere between 8 and 9, right? Listen, when it says 8, then after 8 full years, it was at 8.3. So the answer is not 8. Somewhere in the 9th year, actually 3/10 of the way in through the 9th year, is when it hits 8.5. You hear what I'm saying? And so the best answer is the 9th year. During the 9th year is when it actually surpassed 850. Or in other words, after 9 years, after 9 full years, it definitely has surpassed 850. It hit it at exactly 8.3 years, yes. But it didn't phrase it that way. It didn't ask it the same as the last example. So that'd be the best way to express that. And that is it for now. I did want to show you, I forgot about this. We're not going to, this example, we're not going to do, but you just see, this formula apparently was, I don't know when this was made, but at some point they calculated this, is a prediction of the likelihood of having a customer drive up within the next so many minutes. And so, at this time of day. And so, if you want 10 minutes, it would tell you the probability of someone coming up with a car coming within the next 10 minutes. Next 1 minute, it would give you that probability. And so, but look at it, it's another exponential formula. It's kind of a unique application of it. All right, we'll stop there.